Hello. Yeah, perfect. Yeah, so let's keep it a little bit of interactive session so that I can understand the audience and share more information, which is a little more relevant. And to start off, I'm Sriram. I'm founder and CEO of Power Tusker Innovations, a startup focused on AI and engineering innovations. And we're currently a team of 14 people. It's been a year and a half that we started. We are a deep tech engineering firm working in multiple cutting edge technologies. Most of our team members are polyglot engineers. About me, I've been an enterprise architect, primarily in the area of AI, mobility, machine learning, and extended reality. So that's the prime area I've been worked. I worked with Fortune 500 companies, worked with large startups, and provided architecture for a lot of them. Yeah. So coming to today's topic, which is system design. Okay. So before going to the deep into the topic, I would like to understand in terms of the audience, how many of you are students who know programming language? How many of you are students? If you can let me know in the chat, uh, I'm a student, then I will be able to understand the audience type and be able to discuss more relevant to that. So I have one student here. Okay. As of now, four students. Okay. So how many of you have done a programming a web server? Okay, in terms of using a programming language like Node.js, JavaScript in Node.js, or Python and Flask. Okay, that's interesting. Okay, somebody is experienced in Java. Okay, Java. Okay. Perfect. Okay. So when we develop an application, basically how we develop is we have a database server, we use our laptop or our desktop, and we have our web server in our system. Then we have a database server also probably in our system or probably in another server system. Okay, then we see the REST API in the browser or Postman or client like that. This is the usual system architecture we do. So the two like aspects to creating a system. Okay, one is you have the programming aspect which covers the functionality, logic, and the system ability to perform an operation that's expected in the requirement. And how you achieve that? You achieve that by deploying it in a production server, which becomes accessible to the end users. So this deployment process has a lot of planning and design to be done as well. That is in principle kind of one part of system design. Apart from the programming aspect, you have the server planning and designing aspect as well. So this entire overview of what we're going to see today is about system design in cloud, why cloud, and some overview of AWS system components that you will use for your system design. Okay. So in general, when you create applications, you basically say if you create a web application, okay, in a client server architecture, okay, where the client is a web browser, the server can be in your system, anywhere else, hosted somewhere else in another server. But this is the architecture that you usually follow. This is even little higher level complexity where there is a load balancer. LB is the load balancer, web server 1 to web server 10. Okay, so there usually you start with creating just one web server, but when you think finally when you deploy it, there might be a lot of users, then you create a load balancer over the web server, and you have multiple instances of the web server to balance the load of number of users. So this is how a simple web application client server architecture works. So what do you plan for this? There is a database server for which you need to understand the CPU requirements, RAM requirements, persistent storage requirements, the network setup, how it's going to connect to the web server, and the bandwidth capacity. Okay, right? Then web server, which is again the actual application server itself, which has the functionality, logic, and all of that before storing into the persistence into a database. So that also has that. And of course, there are latest architectures where we have cache and other elements that added to web servers. So let's just take Java, Python, and Node.js. Okay, so we will not consider cache or anything. So there is web server. We need to understand number of connections that can happen to the web server, and based on the number of connections, how do you want to have? If it's a transactional connection, what should be the load of the web server? If it's a batch job which does lots of data the processing, then what should be the capacity of the web server? So you plan all this and you decide how your code is to be, a system is to be designed, and then you deploy it in the system. Based on your accurate estimation, the system performs or underperforms. What do you mean by underperforms? You plan for 100 users and suddenly 1,000 users use the same client URL. Then your system is choking to service. In that scenario, the web server becomes unavailable to provide the service request made by the client. Okay, right? So this is a system unavailability scenario that's there. Underperforming would be you plan for 10, but you're only utilizing, so you plan for 100, but only 10 users are always using the system. So you're overplanned the capacity, and a lot of the system hardware that you purchased is underutilized. Why this matters? Why this matters? Because in large companies, okay, you buy, there are literally thousands of servers, right? So when you unplanned and have underutilized capacity, it's a lot of wastage of money. Okay, so the right capacity planning is very tough, because you plan for 100, then you get 1,000 users, then you go. So always in a standard scenario, people plan for peak capacity. Okay, so this is the biggest challenge that one of the biggest challenge people face in system design. But in general, there is a client, there is a web server, there is a database, there is persistent storage. These becomes the common simple elements of any web application design. Yeah. So when we say we deploy it into servers, I would want you to have a walkthrough of what a server deployment is. When an enterprise has a data center, okay, so they have large, when I say thousands of server, so this is how a server room looks like. This is how a server room looks like, and it's not a typical desktop CPU kind of a server. There is something called racks. Okay, each server becomes part of a rack. Okay, and the server are stacked on one over each other, as you can see in the back of the server rack. Yeah, so you could see a lot of network connections, power connection, all of that made into the at one single cabin. And inside each server, you can see something very similar to what you see in your CPU, desktop CPU, which is a processor, motherboard, and all of that. Okay, then there is a physical security component, which is part of the physical server room, which means that people will not be allowed to the data center room to see what is there. So when developers start programming, they visualize a server to be one single system. Okay, one single system. So that in reality, it's usually a lot more than that when a lot of people use it. For example, Google and Facebook, though they are one or two primarily front-end applications, internally they will have sub-applications, and which cut across and run over thousands of servers. Yeah, because, and similarly, enterprises again, they run organization across the globe. So they will have multiple data centers running across the globe. For example, Citibank will have its own data center in India. It will have its own data center in US. It will have its own data center in Europe and things like that. So there is a large data center team that manages this infrastructure and so on. Okay, so this has become an essential part of production deployment of the application that you create, which is eventually to be used by the end users of the application. Okay, so then came, so in data centers, earlier on, there was only physical metal servers, bare metal servers, which is the standard servers that you see very similar to desktop, which is motherboard, processor, and all of that. Okay, but since there is a lot of underperforming that is happening in terms of infrastructure utilization, so there are 100 servers at any point of time. Okay, only 50 servers are utilized at 100%, and the rest of the 50 servers are utilized only 10%. So which means the rest of the 50 servers are heavily underutilized. So companies like Zen, VMware, Denali, and came up with a software called virtual machine, okay, which is an abstracted system, okay, that runs on a server, bare metal physical server, and behaves like a physical server itself. So this became the change of how systems behaved. So large enterprises started purchasing this software and started putting into their servers. Okay, so each server, physical server, which probably has 32 cores. So usually our laptops have 4 cores or 8 cores, 8 GB RAM or 16 GB RAM. Large enterprises, when they buy a server, it will be 32 cores, 64 cores, 64 GB RAM, 32 GB RAM, 128 GB RAM, 256 GB RAM, 3 terabyte storage. So it's going to be large servers. Yeah. So now they will install virtual machine softwares over them and install guest OS, which could be a Linux OS, which could be an Windows Server OS, and then put the application server, web server over them. So the same server, they could have installed multiple virtual machine servers, which could be utilized. So the 50 servers that we said is only 10% utilized. Now, what they could do, which is say the capacity is 5 servers, the rest of the 45 servers, they can deallocate from this. So the 5 servers, what they will do is they will install 5 virtual machines, 10 virtual machines in each systems. Okay, assuming that all the virtual machine can provide that 100%, 10% capacity and utilize the 100% capacity together. So instead of 50 machines, they would only use 5 server machines, but they will have, each system will have 10 virtual machines installed in them, and each of the virtual machine will work like a physical server itself. So this became the beginning of system design, infrastructure better utilization by enterprises and data centers. Yeah. Okay. So any doubts in this? Any questions in this? Okay, I assume there are no questions. Yeah. So what happened is this history of so large enterprises who set up their own data centers, then there will be companies that set up data centers and rent it out for companies and manage the maintenance of the data center. So this was called as hardware as a service. Okay, so there were a few companies that were providing hardware as a service. Okay, but even at that point, the management of all of this was very rudimentary, very tough. It was not very agile. Okay, that's when AWS or several other companies, Parallel also were working around it. Came this concept of cloud computing, which was to, yeah, infrastructure as service is coming. Okay, this is before that. Yeah, so this is just renting out hardware systems. That's what hardware as a service is. They didn't manage the VMware. It was just the hardware, renting out servers. Yeah, so that was the part. So cloud computing, when it came, companies created a new model out of infrastructure as service, from which is much better than hardware as a service. They wanted to make computing as a utility. What is making computing as a utility? Okay, the biggest challenge is people need to purchase everything upfront. Now they can rent out. So there are already companies that have started renting out servers for monthly rent, which is called as subscriptions. Okay, so now these cloud companies, they wanted to make this as utility, very similar to what we have as electricity. We all use electricity, which is a utility, we only pay the utility electricity bill. Telecom is a utility. We pay only telecom as a utility bill, which is whatever you use, you pay for that. So cloud also, they would want to make into that model, so that infrastructure also they wanted to get into that model. Computing also they want to get into that model. So companies created this beautiful concept of cloud computing and assembled a very beautiful system for all of that, platform for all of that. Okay, so this is you, and how this evolved is, again, companies can use all this infrastructure as from hardware, software, networking. Okay, so to put it this way, um, cloud computing is computing done via internet or network enabled computing. In simple, that is it. What goes behind computing is software and hardware. That's what goes behind computing. So they have to make a utility model to ensure the software, the hardware, right, and the network and the storage, all of them becomes a utility. So whatever you use, you pay. Was the model that these companies created. Okay. So what becomes the characteristics of cloud computing is this. So it's an on-demand model, pay-as-you-go model. Whatever you utilize, you pay. So this, in general, had to have a lot of characteristics in terms of design. So I'll just touch upon some of them because they're little theoretical. Okay, rapid elasticity. What that means is, if I need a server, I need to get it immediately. And if I don't need the server, I should be able to switch off the server immediately. That's when I can ensure I pay for what I can use. So this is elasticity. Yeah. And another aspect of elasticity is, say, first I purchase a system with a certain specification, right? Xeon 2-core processor, 4 GB RAM. But I see that it's not enough. If I want to instantly switch that off and replace it with a CPU system, which is powerful than that, 4 CPUs, 4 CPU cores, and certain 18 GB, 16 GB RAM or things like that, I should be able to do that. Okay. And this should be a measurable service, right? By that, how much ever time I use, how much ever computing I use, only I should be charged for that. So everything that I use should have measurements which will be transparently showed to me, so that I'm only billed for that. Yeah. Okay. Then there has to be large resource pooling, because instantaneously, if I need anything, then means there has to be heavy resources that are readily made available, and resource pooling needs to be made available at a cloud level. Okay. Then there has to be broad network access. Network, like say, in terms of web application, we have WebSockets, REST, we have streaming, quite a different kind of network in terms of data types. Then we have data that is in terms of bandwidth. All this means network bandwidth and the amount of communication of data transfer that's going to happen one server to the other. Yeah. Excuse me. Okay. Yeah. I saw a red line. Somebody needs to ask a question here. Okay. No worries. So these are the essential characteristics of a cloud service. Okay. Then what are the common characteristics? Why this is called common characteristics? Because a lot of companies have come in and have provided multiple approaches how they provide the cloud computing. Okay. That has to be a massive scale, resilient computing. By that, what it means is, say, if we have our own data center and server, the hard disk crashes, okay, or the power supply goes away, right? Then the server becomes unavailable. Then immediately there needs to be a mechanism. This is physical resilience, where immediately the server is made available and immediately it's made possible for the service to continue, whatever application we have deployed in the system to continue, right? The same needs to be a characteristic in cloud. Okay. Of course, virtualization is most required, because that's how we can easily get instant resource access. Okay. And everything has to be service orientation. There has to be heavy geographic distribution, and geographic distribution has two aspects to it. See, there are companies that will have the infrastructure needs in different geographies. For example, large companies and banks operate in different places, right? So they will have geographical needs of infrastructure. Other aspect is availability and the disaster recovery. Okay. Say for example, tsunami comes for a specific data center and the data center cannot be operational. In that case, the end users of the application becomes helpless, and especially if it's a banking application, the server becomes unavailable, then the users cannot access the application. Say for example, an ATM application is accessing a server where current balance has to be checked and the user amount has to be disbursed in the ATM. So if a tsunami is hitting a specific data center, if the server is unavailable for the ATMs, then it hits the data center place, but the users are across entire country, they will not be able to access the system. So there has to be geographically disaster recovery that also needs to be planned for large enterprises. So these are some areas which large enterprises consider in their system design. Of course, there has to be advanced security because hackers shouldn't be able to access the system, and the system has always should be made available. So the delivery mode, there are only 3 delivery modes for cloud computing, which is infrastructure as a service, platform as a service, software as a service. Why I've just added hardware as a service is it all started as hardware as a service where only physical servers were rented out, where companies just take the physical, instead of buying the hardware completely, they used to just rent out the servers or the entire data center, which evolved into infrastructure as service, where these characteristics were being enabled, like rapid elasticity, instant availability of systems and resources. Okay. Then the other delivery mode is platform as a service, where the technology and different aspects itself is made available into the system. For example, usually when we get a system, we install a database server. By that, what we do, we get an empty server, we install first the server operating system, which is Linux or Windows. Then we download our SQL Server or Postgres database. Then we install that. Then we set up the server configurations, right? We do all of that. Okay. And we will have to do this continuously. Always we need to say, if there is vulnerability in the operating system, we need to update the operating system. If there is a newer version of database that is there, we need to update the database software. Okay. And all of that. Okay. Then the data that is stored in the database, we take backup, so that if the data goes corrupt or something goes corrupt, we can restore to the previously working functional state of the data. So these are what we do. All this becomes a service itself, where a database is technology itself is provided as a service. In that case, the backup will be taken care of automatically. The installation and OS patching can be taken automatically. And all of that is done. This is one example of platform as a service, where database platform is provided as a service. Yeah. Yeah, so that's a good question, Karthikeyan. So again, that can be 2 ways. Okay, so it depends on who would manage the server. If the company that is renting out the server, if they want to manage the software that is installed and the networking that is being done, they will manage that. Okay, and in the case where they cannot do that, they do not have the people with such skill sets, they might hire again vendors who are from the same company that is renting out the software, or another company that might provide such services. That answered your question? Yeah. Okay. Then software as a service. See, software as a service is a new era where the functional requirement itself is abstracted. Okay. It's not this database, an order management system, customer relationship management system, which is above the database, which has some functional objective pertaining to a business scenario, or some mostly business scenarios, and the entire software is readily available. You You don't need to develop anything. The business users can go just subscribe the software as a service platform. Business users can directly start using it. So mostly it's like that. So this is the evolution on delivery modes of cloud systems. So the three delivery modes are infrastructure as a service, platform as a service, and software as a service. And so remember this very simple. Any questions in these three delivery models? See, okay, okay. So in general, what is a delivery model is how companies ensure the cloud service that they are providing or cloud aspect that they are doing is reached out to its end customer. Okay. What is software as a service? Okay. Um, HR management system. See, this is usually the system that you guys will do as a small project in your college, right? Where there is employee registration, right? Joining date, name, and all of that, and leave management system within HR management system. These are common projects that college students do. So I'll take this example. Every company needs this, okay? But every company doesn't need to develop this again and again and again. So what certain companies do is they develop this software and make it available for all companies. Okay, which means companies can log into the URL, register themselves, and automatically they can see their entire HR management system readily available. So the HR manager directly logs in, starts entering his employee information directly. Okay, and another company guy again gets into the URL and creates very similar to kind of uh, Zoho CRM. So Zoho CRM is a Indian software as a service company where they've created a customer relationship management system, which is basically means whoever a company is trying to sell, they will put that data into that system, customer information into that system. Very simple way to put it, but it's a very much more complex system. But every company tries to sell something and they gather a lot of customer information. So all salespeople in a company basically put in the um, um, information. So companies can go register into Zoho CRM, pay in terms of per user, whoever using a per month basis, they will go and feed the information about customers and what they are doing activity in terms of customer, what is the deal order that they're going to get from the customer. They manage the sales process using the software. Very similar to HR management system. So people can have one software. So companies develop this, put it into like deploy this as a cloud solution and host it for businesses to come and enroll and use the system. Did that answer your question, Vikash? Hello. Okay. Shankar, you mentioned you didn't get. I think you didn't understand something. Can you mention what you didn't understand? Okay, fine. So then there is deployment. Okay, the deployment is the aspect where how the people use the product. See, in a software as a service, it's a public deployment. By that, a URL will be there. People type the URL in the browser, register, sign up, and then get into the system and can access the system. Okay, that's the usually method. Okay, so the deployment could be public cloud, which is very similar to what I just talked about. Then there is private cloud, which is similar to only people belonging to a specific network can access the specific system. So enterprises use this where they have a network configuration in such a way that it will be available only to the people within that network. Okay. So in this scenario, the data center also and is hosted by the company itself, and it's made available only within that network. Virtual private cloud is something like you go rent out infrastructure from somebody else, then have a virtual private cloud because the system is in the internet. So you create a virtual private cloud, which means that only still the users belonging to that specific company can still access that. So for example, AWS that does this. AWS is a publicly available cloud system where all companies access the AWS using internet, which is publicly available. But if I have to restrict my company people to use the infrastructure only allocated to me, then I will group all the systems into something called virtual private cloud, or group of people, a subset of people within a specific virtual private cloud, and only provide access to them. Okay. And hybrid cloud is a scenario where there will be public cloud as well as our own private or public data center. Okay, so then companies wants to see, there have companies cannot immediately take all their system into cloud. They might have beautifully running, functionally running critical systems that are running in their own data centers, but now they want to extend the functionality. So they might only extend the functionality in the newer cloud technologies, or like AWS or Azure or Google, but they would not disrupt whatever is in their existing data center. So in that case, they will have to there is a concept called hybrid cloud, where they create direct connect interfaces between the private data center and the public cloud or virtual public cloud infrastructure, and ensure the systems works together. Yeah. Then there is community cloud. Community cloud is a very different concept, where this hosting of the server is shared with the community. Somebody says, hey, today I will provide this my system to be part of this cloud infrastructure, so that somebody can use it. For example, blockchain mining and all of that, lot of community clouds are available, where people if they have excess system in their house, they provide as if it's a cloud system. It becomes part of a community cloud. So these are the deployment models of cloud. Yeah. AWS has public, private, and all of that. So AWS is very sophisticated. They have all options. Yeah. Okay. So then now what goes into cloud technologies and systems? Yeah. Um, so cloud software, the software that enables just plain hardware set of servers to become those characteristics, rapidly elastic, right? Um, like highly the other characteristics as well. Instant. Let me just, yeah, on demand. Okay, measurable service. So all these software that make the standard hardware become cloud enabled or cloud characteristic. So those are these software. Then there is infrastructure services, the software that resides over cloud software and provide you storage services and web services and other services. So AWS infrastructure aspect comes in these places. Then there is platform services, which is like technology that becomes over infrastructure as service and provides those capabilities. Then there is software as a service. Yeah. So if you look at cloud, there are 4 sections of technology you can be part of, right? Whether you take the infrastructure as service and create a platform, or you create platform as a service and you create a SaaS service, or you create infrastructure as a service and directly create SaaS service, or you want to work for creating beautiful technologies for Google and Facebook to create these technologies, then you go learn technologies to create cloud software itself. So these are the 4 areas of technologies that matches the whole cloud era, where you create the cloud software itself that enables cloud characteristics. Then you create technologies that enable infrastructure as service, or then you create technologies that you can create a platform as a service or software as a service. So these are the 4 areas that are available. Yeah. So everybody is moving to cloud. Why? Because instant agility and dev productivity. See, the developers don't need to, lot of new age developers, like they develop in their laptop. They don't understand the server deployment because mostly they've done server cloud deployments only. So they don't they don't need to think about network wiring, how the network architecture needs to be set up, what is the network IP to be set up, and all of that is kind of gone away. It's still there, but it's kind of gone away, because in with cloud technologies, people just need to, like, uh, provide some secret key and all of that, and they connect to servers and just start coding and deploying their code. So it's become much more easier, which is very agile, and the code management and team management has become very effective. Okay, and data center consolidation. There are multiple data centers, and people have different reasons why they have multiple data centers. Now they can all bring it to one place. Yeah, and easy, and it becomes easier to manage that than having data centers in multiple places with multiple technologies, multiple vendors. For example, one data center might have, in India might have HP as the primary vendor. One data center in US might have Dell as the vendor. So there are a lot of practical complexities that people face when they run their own data centers. Okay, that all goes away because now you don't worry about the physical infrastructure and what is the hardware. You only look at the service, right? For you, storage is given as a service. You do not know in cloud you're storing in a Western Digital hard disk, Seagate hard disk, or anything. You only call something like in AWS, there's something called elastic block storage. You only get that storage. You say, I need 1000 GB. I need 2000 GB. That's all you worry about. You don't need to understand whether, like, the Seagate hard disk is best, whether Western Digital is best. That's all taken care of. Yeah. Otherwise, companies used to architects, system architects needs to evaluate vendors by their performance, the hardware capacity, and all of that, for procuring physical hardware for the data centers. And when you buy a service, you don't need to do a lot of stuff. You have all of them readily available to purchase and innovate. For example, machine learning, right? People started coding in Python, in TensorFlow in their own systems. Now, setting up TensorFlow in a server is not easy. Okay, but now with AWS or other cloud provider also, they are readily available. You click, it will be available. You put your code, it will start executing. Matter of 5-10 minutes, you can make your entire process production ready and innovative. And there are also very nice services. They say, for example, AWS has something called SageMaker, which is a very nice machine learning service, which is the platform as a service. Okay, where people can go use the platform to create very sophisticated machine learning models. So the technology standardization and all becomes easier. Okay, otherwise what people do, one person will go to a technology called R for machine learning, person might go for Python for machine learning, and that will be chaos. But rather with SageMaker, there's one place, it's only one service, and people just use the same service across the company. So the people who work together can also talk very relevant language. And of course, cost reduction, as I shared with you, instantly when they need, they create the instances. When they don't need, they remove the instances. Okay, and there is large scale compute. See, the services like Amazon or Google, Azure, these cloud providers uh, like provide very complex servers in terms of number of cores. There are, like, you can go and ask them, I need a 2 to 6 core system, 5 terabyte RAM server, which is crazy, right? So, but these crazy infrastructure also can be made available with these guys. And even the normal, so you can go and ask them, just the not ask them, basically by ask I mean, go to the platform and instantiate 10 servers with 64 cores and 256 GB RAM. In an instant, all these 10 servers with this configuration will be made available. But in physical reality, if you look at it, procuring this will not be immediately there. You need to put a purchase order. The vendor will need to ensure he assembles the system, and it's made delivered to you. And then you need to install the OS. It takes a long time, but ensuring you could do the large scale intensive workloads, it happens immediately. Yeah, and facility and real estate decisions. You don't need to host. have physical space for the data center. Yeah, so these are the common reasons that everybody is moving to cloud. Okay, we see that a lot of enterprises have their cloud presence, a lot of businesses have their cloud presence. By businesses, what I mean is companies that don't even know technology, but they still use SaaS software, like accounting software as SaaS, HR software. So they still use cloud in one format or the other. Yeah. Okay. Then tech-based startup, Netflix, Dropbox, all these startups that we know, Airbnb, all these tech startups, which are now very huge, they all started as a cloud base and started creating such complex cloud-based systems so that the world is able to access them. Yeah. Okay. So let's go and talk a little bit about AWS. Okay. So AWS was the very famous infrastructure as a service guy who came March 2006. They are the early birds. So when they came, people were completely skeptical of them. Today, AWS is a very common name in cloud, but when they came around, people were very reluctant because every company's confidential data, they're going to put it in the internet. Okay. So they were afraid, and AWS came first. They convinced a lot of enterprises and companies to do that. Today, they are in 22 regions, okay, 69 availability zones, 266 points of presence, and 140 plus countries are heavily using AWS services on a daily basis. So this is just the infrastructure as a service aspect. By infrastructure service aspect, what is being utilized is server, okay, storage, network bandwidth, and uh, the compute capacity. Yeah. Um, I think I missed one more point in this. See, AWS especially has a fiber cable put across the world to connect their data centers. Yeah. So the internet connectivity between their infrastructure is amazing. That's something I'm not sure about whether other cloud providers have that, but AWS has that. Okay. So this is infrastructure as a service. By this, what this means is if I need to set up a server, I cannot set up a US server. I can if I want to, but there are laws. See, Indian law is little open. I can set up a software server anywhere. Okay. Um, uh, but say US or Europe, they have something called GDPR, which means the software created, which gathers customer information, the server needs to only reside in their own countries. It cannot reside outside their countries. Okay. So there are some regulations, some countries in terms of have their data protection and all of that. So the AWS has so many regions, and all these regulations are being met. Okay. So what are the other cloud providers? Azure is from Microsoft. Google Cloud is from Google. See, these are the major three guys. There are quite a lot of others, Cloud Control S, and with who, of course, IBM, and Oracle also is there. SAP also used to be there. Okay. And but SAP is closed down its cloud operations now because they're not able to compete with these major cloud guys. Okay. Um, of course, there are quite a few are there. Okay. See, I'm not exactly sure what are the virtual machine technologies that AWS is currently using, but they started off with Zen Server. Yeah. So this is the brief overview about infrastructure as a service in AWS. Then there is platform as a service and software as a service that AWS has come up with. So AWS became a behemoth in infrastructure as a service. Okay, and they started creating, extending their platform into a platform as a service and software as a service. So they now have 175 plus fully featured services, right? For example, they have ready-made capacity for business applications, which means SAP ERP can be hosted completely into AWS. Oracle e-business suite. These are all ERP systems coming from other technology companies, yeah, which can be readily be set up. See, there are developer tools. Okay, developer tools in the sense, see, we all now use Visual Studio Code, right, to develop applications from our laptop or desktop. But all these developer tools, even Visual Studio Code kind of interface is available on browser. You have an AWS account, you go use the respective Code Guru tool, you can develop it there. You can do code review and all of that. Compute is where EC2 comes into picture. Then there is Dockers and all of that. So it has 175 fully featured uh, elements. Yeah, of course it has Docker support. So this session, it was a primary overview about uh, uh, basic infrastructure design and not container or Docker infrastructure support. So, but currently, see, there is something called cloud native. Okay. Cloud native development is container based development or virtualization based development. So AWS has full blown service capabilities in cloud native based development, all of that, container, Docker. So there are lots of services that are available. Kubernetes variant EKS is available. You can use standard Kubernetes. Then there is ECS. Then there is ECR where you deploy your Docker images. So there is a lot of services that are available in the container world also. But today we just wanted to share the basic overview of bare metal or something around the basic virtualization in terms of IaaS. Yeah. So they have all this with them. So let me just see whether I missed out any question. Yeah, Sri has asked me a question. Is training on one is enough for others? Is also, I didn't get that question. Sri, can you repeat that? Okay, so let me assume, see, all these cloud technologies in cloud companies are very similar. Okay. Say if you learn to create system design in AWS, you technically should be able to design for Azure or Google as well, because the approach is same. How they have implemented certain things, there might be minute changes or but mostly they're all very similar. So if you learn to use and design and deploy for one cloud provider, you should be able to do it for others. If that's your question, I think did I answer your question, Sri? Hello. Okay. So yeah, I'll go on with the um, session. So yeah, so I'm going there a bit. Okay. So so these are the core services that people will use. Okay. Commonly used core services of Amazon Web Services. Okay, so the 5 core services that are very traditional system design approaches. EC2 is a elastic compute cloud, which provides a system which is a combination of CPU and RAM, right? With some basic storage for the OS and application deployment. Yeah, it's equivalent to a system, it's equivalent to a physical system, but it's a virtual system that's provided. Then there is elastic block storage, which is equivalent to hard disk. See, ideally, data centers use, so we usually in a laptop and desktop, we have something called plain hard disk, right? In companies, data center, they use something called SAN storage. Okay. So this is equivalent to that. But this is hard disk, persistent hard disk storage. This is hard disk. Yeah. Then there is elastic simple storage. This is a service that is there. This is again a very commonly used to store objects, which is video or files or documents or things like that. Then there is elastic relational database service. Okay, this is a managed service again provided by AWS. This, okay. So where you can configure your MySQL or Postgres or other databases in elastic relational databases. Then there is something called simple queue service, which is a queuing service where people provide us queues and the queue is handled. This is to handle workload. Yeah. So if a server can only handle certain load, you basically put it into a queue and say only you will process certain number of queue elements at one time in the system. So this is how you manage your workload and ensure systems performs continuously. Yeah. Then there is Lambda, which is serverless. So Amazon was one of the first to come with serverless. What they've done is, instead of buying, even renting out one full server, right? You basically are developing entire code, a set of hundreds of functions. But say if there is only one function that's going to be used mostly, can we deploy that one function alone as a subscription unit, is what serverless is about. Okay, so you don't need your entire application, but your entire application can be split into 20 functions. Like if there are only 20 functions, and each function will be a lambda, and every function that is called by function call, they will bill. Here, by you say in EC2, which is a system. So we switch on the EC2, which is equivalent to switching on a physical system. You will be charged till the system is switched on. For example, per hour it's $1. Let's assume it's not that much, but you switch it on for 5 minutes, you have to pay $5. Lambda, if you have one function which is you use that Lambda REST API in your mobile application, which is an order booking application. Somebody books an order, that per order, it say it's probably $0.001. So you'll only pay $0.001, right? So you can optimize your um, cost to server and all of that at a function level of actual utilization by the application and not by your infrastructure. So that's where AWS has come, and all cloud providers have some serverless functionality. In Azure, it's called functions. I think in Google also it's called functions. And it's available in the serverless is available in all cloud providers. But if you look at the general system design, EC2 is the server equivalent, physical system equivalent. EBS is the storage equivalent. Again, there is a object storage where you can store objects as a key value pair kind of a system. Then there is database itself, which is relational database service. Of course, there is NoSQL. Amazon has their own NoSQL database, okay, which is a document DB. Amazon has their own relational database, has Aurora DB, which is all platform as a service. So I'm not talking about platform as a service for now. I'm looking at infrastructure as a service and managed services around them. So these are the things that I'm covering for the system design. So these are the most widely used system elements. So what makes this easy is Amazon has this philosophy of infrastructure as a code, okay, which means you can access the entire AWS platform using a CLI, SDK, and a management console. Management console is just a web UI. If you type aws.com, you have an account, you log in. After you log in, you see the management console, right? SDK is available in a lot of technology platforms. It's available in Python, Java, Node.js, and all of that. See, if you have to create a request, okay, to provision a EC2 system, you can use the AWS SDK and EC2 API and ask a respective server to be instantiated. And that will be on your credentials with AWS and AWS server. So programmatically, you can instantiate servers. Programmatically, you can bring them down. And so this is before your application deployment. Post that, you can do your application deployment in those servers. So you can programmatically manage all of that. So AWS provides all of that. Then there is CLI, where there's in the terminal, you connect using AWS CLI, which you install, which is available in on desktop clients, or it's available for Mac, Linux, Windows, and all of that. Type the command, and you instantiate, use the commands to instantiate these systems. Yeah. So to quickly show, so this is how an AWS console looks like. Before sharing that, let me share. Yeah. Can you guys see the management console screen? Hello. Yeah. Okay. So As you can see, all these services are available. So they are categorized by the functionality that it means. Compute, as I said, is the capacity. Yeah. So if you go to EC2, I can, at a click of something, I can create an instance. Okay. So I am launching an instance. So based on costing, this is saying it's free tier eligible and all of that. Okay. Others, you need to identify their price based on your price requirements and what you can afford. You choose systems. Yeah. See, see, there is deep learning AMI, which means I can, if I set this up, all deep learning software installed in this is readily available. Yeah. So let me go and instantiate this system. Okay. So it's asking me to choose the kind of server size. Okay. So this is free tier eligible, which means I don't have to pay. Uh, like there is some free tier that Amazon provides that says 750 hours of EC2, you can use it for free. So we recommend everybody, if you have not used AWS, you can go create a trial account and you will get a lot of free tier eligible services, and you can look and work on all of them and learn the services as well. Yeah. So if I say review and launch, shows what I've selected. Yeah. Instance details. So this one is a one instance. So let me go back and show what is that. Yeah. Okay, let me cancel this. As you can see, there's something called vCPU. It doesn't say CPU, it says virtual CPU, which means one core system, 1 GB RAM. Okay, so this is what I get with the system. And there is an instance storage, which is EBS, a hard disk. Okay, and which is EBS based. Then I am reviewing and launching it. It's showing whatever I've selected. Okay, and the details of that. So there is a lot of things called availability zones and all of that that can be done. It's asking me to create a security pair. Already have one launch instance. Okay. So now if I go view my instances, see I have, so you can see the instance is getting ready. So I have already one instance that is running, one instance that is getting ready to be set up. So this is how I create server. Based on a click, I can make a server available. Then what I will do, I'll connect this server using SSH, using my terminal in my system, um, and I can upload the. Hello, is everybody able to see my screen? Hello. Oh, sorry. I think now you're able to see my screen. Okay. I didn't realize my PPT was only shared. Okay. Let me. Yeah. So this is my AWS Management Console, which I have logged in. Yeah. And after logging in, I can see all the services that are available. So there are some core services that I shared, right? Right. EC2, S3. So EBS is attached to this compute itself. Okay. And RDS. So these are the common services somebody uses. Say, for example, if somebody creates a JavaScript based website, e-commerce website, they will be using heavily S3 for the e-commerce images storage and loading. Yeah. And for and of course there is a web server and a database server that they will use. Okay. Then if they're creating a plain database application, they might use just EC2 and RDS, and they can choose to do that. So all these services are available across different categories, yeah, of products. So EC2 just was what I was just showing was, go to EC2 launch instance. Yeah, I select the OS version and all of that, and I just say select. Yeah, and I say the physical server capacity I need, for example virtual CPU memory and all of that. Yeah, okay. So then I say review and launch. It shows what I've selected. Then I'm launching it. I'm saying choose the existing key pair, launch instance. So this is as simple in terms of launching a system. So then you've requested for launching the system. So this request is initializing. Your system is getting ready, right? After the system gets ready, you will get a public IP. Yeah. Then in the using the public IP, you will connect from your laptop using SSH and upload the code into the server using FTP, or by different means you could do that, and then deploy the running software in the server. Yeah. Similarly, you will EC2 also, RDS also you will enable in the same fashion. Okay. So there is free tier accounts that are available. Uh, Everybody can register and they can get a free 12-month trial period, and they can go ahead and create a thing. So here RDS is again, I'm saying MySQL database. Okay, let me know. EC create. Okay, admin database password. Admin. All this can be done programmatically via SDK or by command in your CLI itself. Yeah, but you need to have the privileges in your AWS system to be able to provision this. Okay. So I've created a database and now it is ready. So its status is creating. So let us go back, and while this is creating, let's go back and see to EC2. Yeah, so this is running. So this is my public IP. Yeah. So this is my public IP. Okay. So if I connect using SSH, using this from terminal, I would be able to connect to this server. Okay. And similarly, RDS. Okay, DB instances. Yeah, so it's allocated this specific instance for me. So we go to the details. So the endpoint is still getting ready. Okay. Yeah, so you will have a endpoint that will be available, and public endpoint that you can use it and connect, use like just like you connect your server. Say you have MySQL Workbench locally installed. Instead of your local IP, you will give your AWS IP, and you will start using the database. Yeah. So this is very primary overview of AWS in terms of system assembly. So let me now stop this and share the PPT. So initially we started with the web design, which is very similar to this, right? There is a web browser, there is a web server in different technology, there is a database, there is a file storage. So we access a very similar common enterprise use case is SharePoint, which is a .NET based content management system. Okay, so this is how I create a SharePoint web portal, and there is an administration portal. This becomes the database server. You guys are able to see the screen, right? Hello. Okay. I'll come back to the questions in a few minutes. Just let me finish this design. So this is one sample system design. So if you see here, AWS is mentioned, which is okay, which represents the public cloud. So users will connect via remote or anything in this public cloud. Okay, and it becomes a virtual private cloud. Because why they need to connect via remote with the interconnectivity in this is because this is a virtual private cloud that is set up, and then we have a load balancer that is set up, which is between two availability zones. So if there is extreme load, then it will be balanced in this availability zone. There is a NAT gateway that is set up, which is a network address table, which provides the facility for the internet gateway to be able to connect to the public subnet, which is again mapped to the servers and the endpoints. And if you can see this web servers configured, which is the web tier, there is application tier, there is database tier, and there is Active Directory. So usually companies have their own identity management system, which is the Active Directory, and here is the Active Directory system. So you can see the backup and all of that setup. So together, these two availability zones, there is availability zone 1, you can see here, availability zone 2, you can see here. So elastic load balancer will be balanced between load between these two availability zones, so that the system has high availability continuously. Yeah. Okay. So any questions in this system architecture? I'll come back to the questions in chat, but any questions in this system architecture? See, most of the regions have 3 availability zones. Okay, you can select up to 3 availability zones in terms of the availability zones that you, number of how much high availability that you want to provide. And disaster recovery that you want to provide. And in terms of Shweta's question, okay. See, I'm not able to go back. Like there's some issue with my Zoom. I think I missed to answer some of the questions. Can you guys type that back? I can see Shweta's question where it says, can you explain the facility of IAM user in AWS? Okay. See, IAM has a history in terms of evolution. Okay. So IAM is the identity and access management to the services provided in AWS. So the IAM user who has certain privileges and roles and policies set to them based on what the IAM user can do, they can instantiate. For example, my solution architect in my company has all privileges in our company AWS account. So he can provision any easy to instance at his will. But a lot of other developers, they do not have the role to administration access where they can instantiate anything or administer anything. They can only access specific server in terms of deployment or code or anything like that. Okay. So IAM is a gateway of user identity to access AWS services in terms of its infrastructure as a service or platform as a service. Did that answer your question, Shweta? Yeah. Karthikeyan, did I answer your question in terms of zones? Yeah, I think the floor is open for questions for a few more minutes. Then I think we can finish it up. Yeah, yes, go ahead, Shweta. Hello. Hmm, I'm not sure what you want to achieve from that, but technically, the multiple key value pairs can be created, but it doesn't um, um, make much sense to create multiple access key secret keys. Any other questions? Yeah, I think okay, AWS career path. Okay. So AWS career path. See, every company is trying to move to cloud. Okay, and AWS has surely captured a huge market in terms of cloud providers. It's 34% or something in terms of market share. So there are AWS certifications. You can learn. I think the first certification people usually do is cloud practitioner or developer certification, and there is already uh, good demand for such certification. And after some experience, people get DevOps certification. And yeah. See, it's tough to say which cloud provider is best. AWS, Azure, Google. In terms of core services, I think most of them are very similar. But in terms of lot of services that are available, AWS has most number of services. And next to that is Azure. Google is a little more lagging behind. But in terms of core services, all of them are almost the same. And um, there's not much difference, and mostly people use only the core services. Now 80% of the use cases will be about core services. See, today in terms of overview, I only took a web application system design scenario and moved through. I didn't take machine learning or big data or anything like that. So the difference, and this again was a very simple high availability replication scenario in terms of web server also. There could be high complex designs that companies use in terms of what they want to use and what they want to create. Yes, you're correct. You're correct, Nirja. Yeah. So I think we've come to the end of the session, and you can fill in the feedback. Hope you had a good session and some learning out of this knowledge sharing. All the best, you guys.
Yeah.
Be safe.
Hi all, this is Harun representing GUVi. Thank you, Mr. Sriram, for this wonderful session. I hope it was helpful for everyone. Thank you for spending in your time, Mr. Sriram, for this session. Especially due to this corona outbreak, people are struggling at home. I think this webinar will be really helpful to them. So thank you so much, Mr. Sriram.
Most welcome, Harun. Yeah.
So to all the participants, so due to this, to make this time useful for you, we at GUVi we are providing our courses for free, and we also have much more webinars to come up. So keep updated. Yeah. Thank you all. Thank you, Mr. Sriram, once again.